with your arms? Just so we can make sure we're all on the same page. Looks good.
The standard that I was teaching today is a Florida standard that dealt with geometry. It's the first geometry standard, and it asks the children to be able to identify right angles, acute angles, obtuse angles, parallel lines, perpendicular lines, and then lines and line segments. So the typical geometric terms is what we were looking for the children to be able to identify.
All right, how about can you show me an acute angle, please?
First, I made sure that students were comfortable with the vocabulary, and so I began the lesson by reviewing the geometric terms by having students act them out, hold up their arms to show parallel and perpendicular lines so that I could really get the kinesthetic learners involved. And then I gave students bags of polygons that contained an equilateral triangle, a right triangle, a square, a rectangle, a rhombus, a parallelogram, a trapezoid, and a hexagon. And students had to take those polygons and they had to decide how many sides they had, how many right angles they had, how many obtuse angles, how many acute angles.
One pair of parallel lines. Perpendicular?
Yes.
Right angles?
Yes.
They were able to draw them and write about them so that the students who are more artistic or visual had a place where that they could shine. And then the entire time they were talking in groups. And so that let my auditory learners shine as well, because there were some that wanted to talk about the problem but not write it down, which worked fine today in a team, because as long as they had somebody who wanted to write it down, and in a group there was someone who did, then they were fine. So everybody kind of got a chance to do what suited them best, but then as a whole, the whole group came up with a product that worked. And then for the next part of the lesson, the students were challenged to do some more higher order thinking, where they had to classify the polygons based on either the types of lines they had in them, perpendicular or parallel lines, or the types of angles they had in them.
So you guys are doing your whole thing based on parallel lines. I love it, I love it, I love it. And then when you're done, can you do an explanation in the middle of what you did, and then maybe tell your numbers to go with it, so we can have some words to go with the sort?
All the quadrilaterals have angles, the degrees that equal up to 360 degrees. Each quadrilateral has that, but since that has 6 sides and not 4, or 6 and not 4, and since that's a quadrilateral, since that's a quadrilateral and that's half of that, you plus 360 plus 360, and that would be equal 720. So a hexagon has
twice as much as it
has 720 degrees.
After they did this, I challenged the students to look at each other's work and ask each other questions and be able to justify why they put them into groups that way.
We did it by 0 pairs of parallel lines, and 1 pair of parallel lines, and 2 pairs of parallel lines, and 3 pairs of parallel lines.
So you guys just really focused in on the different number of parallel lines you saw, and that's what you decided was your whole classification system. I love it. It makes sense.
And then finally we discussed how this could apply in the real world. Students came up with different jobs that you might need to use this type of geometry in.
Why do you think a carpenter would need to know about this kind of stuff?
Because like if he's building a house and he needs to know the length of a stud or something that's at the wall, then he would have to know how the angles and how he's going to put a door there or a bathroom, how big the bathroom is.
Look at our door. What kind of angles do you notice around our door? Right angles. And if those angles are not correct, 90-degree angles, it's going to be very hard for us to get in and out of the door if you didn't measure correctly, if you're the carpenter.
The last thing that they did was they thought about if they were an architect or an engineer designing something, what would they design, and they worked in groups to have big pieces of grid paper to draw. A lot of them drew their dream houses or dream cities, and we talked about the importance of parallel lines and perpendicular lines and right angles in those drawings. The first thing that I looked for to be able to understand if my students knew this concept was on the chart when they were just counting the number of parallel lines and the number of perpendicular lines in the polygon. I was looking for groups that agreed with the number of parallel lines that were in their shapes. For example, they were pretty quick to figure out that a square has 2 sets of parallel lines. That showed me that they understood the concept of parallel lines, but it was a little trickier for them to figure out that a hexagon has 3 pairs of parallel lines. So I was looking for them to be able to apply the vocabulary to the polygons and then come to an agreement with their team. I would say the best thing about the new Florida standards is the real-world applications that the students can do with them. The math practices that are in place for K through 12, such as mathematical discourse, looking for patterns, these are things that no matter what standard you're teaching, if the kids know how to back up an argument, if the kids know how to justify what they're doing, if the kids are stuck but they know how to look for a pattern, if the kids know how to persevere, to me, that's the best thing about the new standards, is that we're not just trying to teach them content now, we're trying to teach them how to be mathematical thinkers.